Students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 6, RK Bali navigation book. So let's begin. Question number 31. Aircraft is flying in an area of high barometric pressure where regional pressure setting is 1000 millibar. It now transits into an area where the QNH is 960 millibar. So that means it is flying from a high pressure area into a low pressure area. But altimeter subscale is maintained at 1000. That means the pilot, after flying or after entering a low pressure area, forgets to reset his altimeter setting to a new altimeter setting, 960 millibars. The aircraft will now be flying 1200 feet lower, 1200 feet higher, 120 feet higher. So let's say here is an airspace. This is a high pressure area. Okay. The aircraft flies from this high pressure air mass into a low pressure air mass. So this is low pressure area, this is high pressure area. Okay, so aircraft flies from this high pressure area, same altitude, into a low pressure area, right? So the pressure here is 1000. Next, the pressure here is 960. So always, as a rule, whenever you fly from high pressure area into a low pressure area and you do not reset your altimeter pressure setting, the true altitude, in that case, the true altitude, which means the real altitude of your aircraft is lower than the indicated altitude. True altitude is lower than indicated altitude. Okay, I have also made a detailed video on altimetry errors and uploaded that to my channel, so do watch that video lecture. In that video lecture, I have explained everything in detail, everything related to barometric errors of altimeter, temperature error. So in that video, I have explained the concept, elaborated on it, and you will find that lecture very useful. So over here, remember, whenever you fly from high pressure air mass to a low pressure air mass, the true altitude of your aircraft is less than indicated altitude. So your meaning, your altimeter will indicate that you are at 5000 feet. But in reality, the true altitude, actually, you may be lower than the one indicated altitude. So you may be flying at 4000. Okay. Yeah, altimeter indicates 5000, but in reality, you are at 4000 feet. So that is the meaning of this statement. True altitude of your aircraft is lower than indicated altitude. So that means at in high pressure area you are flying at this level. When you enter low pressure area, you will be somewhere lower than that level. Somewhere here, 960 millibar. Okay. So the difference between these two levels, difference between these two levels, we have to calculate this difference between these two levels. Now that is equal to pressure difference. What is the pressure difference between them? 1000 minus 960 is 40 millibar. That is equal to a height difference of 40, approximately 40 into 30. That is equal to 1200 feet. Right? We know the rule that 1 millibar equals to a 1 millibar pressure difference equals to a height difference of 30 feet, approximately 30 feet, accurately 27 feet. So it will be 1200 feet difference. So when aircraft enters this low pressure area, it will be 1200 feet lower than this level. Okay. So the correct answer is 1200 feet lower. High to low, watch out below. Next, inertial navigation system relies on satellite radio positioning waves to fix position, accelerometers only to fly aircraft along a given set of waypoints, accelerometers and rate gyro stabilize platform to measure acceleration and velocity and keep a continuous log of progress from initial erection to shutdown. The correct answer is option Charlie. Your INS relies on accelerometers and gyro stabilized platform. Next. What inputs are fed to the air data computer? Very important. So inputs such as angle of attack, total air temperature, static pressure, total pressure, and all aircraft, that is alternate current electrical power. Okay, so these inputs are fed to the air data computer. You will select that option which has this statements: angle of attack, total air temperature, static pressure, total pressure, and alternating current. Now next question, question number 34. GPWS may give warning of what things? Excessive sink rate, excessive closure with terrain, excessive proximity with ground when not in landing configuration, excessive angle of bank. So over here the correct statement is excessive sink rate, yes. That is given by GPWS mode 1. Excessive terrain closure rate, yes. That is given by mode 2. Excessive proximity with the ground when you are not in landing configurations, meaning the flaps are not extended, the landing gear is not extended. So in that case, mode 4 gives you the warning. Now angle of bank, excessive angle of bank is not the option. We don't have that warning given to us. So the correct answer is option Alpha, Bravo and Charlie are the right ones. So option A is the correct answer. So do watch the video lecture in which I have made a detailed video lecture of ground proximity warning system chapter. I have marked important points from that chapter and uploaded it. So do watch that video lecture, mark the important points from there, and keep revising these important points for your exam, CPL, ATPL, and airline, as well as for type rating. So ground proximity warning system is very important theoretically and practically also. So there are 7 modes here. Mode 1, like I said, excessive descent rate, excessive terrain closure rate, mode 2. Mode 3, descent after takeoff. That means once you lift off and your aeroplane sinks, so that at that time you will get mode 3 alert and warning. Also, after go around, let's say after go around, you have to maintain a positive rate of climb. And if you happen to sink, in that during that maneuver or that phase of flight, again mode 3 will be activated. Mode 4, unsafe terrain clearance. Okay, that means your landing gear is not extended or flaps are not in the landing position. Mode 5, descent below glide slope. Okay, 1.3 dots below the glide slope. Next, mode 6. We don't have mode 6 actually. It's mode 6 is situational awareness. So bank angle, not all aircraft have this mode available, but minimums, yes, whenever you reach minimums, that is your decision altitude, decision height, minimum descent altitude, you will get this call, minimums call, when you are about to reach your minimums. Mode 7 is wind shear information, so wind shear will be warning will be provided to you. Next, inputs to TCAS2 include TCAS2 means there is TCAS1 and TCAS2. In TCAS1 you only get traffic advisories. In TCAS2 you get traffic advisories as well as resolution advisories. So inputs, what are the inputs provided to TCAS2? Mode S, transponder to coordinate avoidance maneuvers. Mode A, transponders providing traffic advisory and resolution advisory. Mode C, transponder coordinating avoidance maneuver. So correct answer is mode S. If you want the resolution advisories of your aircraft and the traffic aircraft to be coordinated, mutually coordinated, then mode S transponder is required. Only and only then both your resolution advisories maneuvers will be coordinated. Meaning, if your aircraft gets a resolution advisory of climb, the traffic aircraft, Okay, the traffic aircraft, the conflicting aircraft will get a resolution advisory of descent at the same time. So these advisories are coordinated. One gets a climb info command, another plane gets a descent command. So that's why they are coordinated, and that to happen, to achieve that, we require mode S transponder. Mode A transponder cannot give you resolution advisory. It can only give you traffic advisory. Mode C transponder can give you traffic advisory and resolution advisory, but resolution advisory will be limited to your aircraft only. Okay, in case of mode C, the resolution advisories of your aircraft and the traffic aircraft won't be coordinated. Okay, so that is wrong. For coordinated resolution advisories, you need mode S. Next. After applying GPS differential correction to a raw position, the refined position will be absolutely accurate, accurate, accurate 1 meter, accurate 1 to 3 meters. So correct answer is option Charlie. Next, in FIS, that is Electronic Flight Information System, the triangle symbol represents what? So this is the triangle symbol that is they are talking about. So this triangle symbol represents aeroplane. Okay, okay, aeroplane. It's available in map mode. Okay, map mode, VOR, ILS mode, and is colored white in color. So it is colored white. Okay. Now this is wrong. Active waypoints are diamond shapes. Option A is also wrong. Next. To increase maximum theoretical range of pulse radar system, what will you have to do? So very important, I have covered this in my radar lectures of secondary radar, primary radar, airborne weather radar, DME. So do watch that video lectures. So maximum range, maximum theoretical range is inversely proportional to pulse recurrence frequency. Minimum theoretical range is proportional to pulse width. Okay, so in order to increase the range of your aircraft of pulse radar system, reduce the PRF and increase the power. Increase the PRF, reduce the power. Increase the PRF and increase the power. So since it is inversely proportional to frequency, you will decrease the frequency, so the maximum range, achievable range increases. Right? So correct answer is option A. Reduce the PRF frequency and increase the power. Next, a magnetic compass must be swung after a short-term change in latitude, a long-term change in latitude, short-term change in longitude. So option Bravo. Okay, after a long-term change in latitude, when you cross many latitudes during the course of your flight, you must swing your magnetic compass. Last question, when a mode C interrogation is responded to, vertical position is coded and transmitted. So vertical position is referred to what? Now mode C capability of your transponder means altitude reporting capability. The air traffic controller will automatically get to know the vertical position of your aircraft. Now this vertical position is nothing but pressure altitude, which is a reference to pressure setting 1013.25 millibar. Irrespective of the altimeter setting that you have set in your altimeter, sensitive pressure altimeter, okay, this mode C interrogation will be altitude capability will be with respect to standard pressure setting 1013.25. So the correct answer is 1013.2. Okay, it's not QNH, it's not the QFE that you set in your altimeter. Irrespective of all that, it will always be with respect to standard pressure setting 1013. So this ends the lecture. I hope you have understood the 10 questions that I did in this lecture. Keep practicing, revise the theory chapters, mark the important points, keep revising them, and answer as many questions as possible. Do watch all the video lectures in which I have solved the sample questions from all the sample papers. Okay, so that will be a very good practice, and your confidence will increase, and also you will get to know how much time you need to solve sample questions from sample paper. So it will give you an idea of time management. I request you all to share this video lecture with your friends who are also preparing for various exams. Subscribe if you haven't yet, and hit the like button if you have liked this video lecture. Thank you.